Welcome to our channel Biswanka's Math Exclusive. This is my part 4 video on multiple integral. Now start with this example. Double integration 1 minus x square by a square minus y square by b square dx dy equals to 1 by 8 pi ab over the positive quadrant of the ellipse x square by a square plus y square by b square equals to 1. Now start. Double integration r 1 minus x square by a square minus y square by b square equals to dx dy. Then putting x by a equals to capital A, y by b equals to capital Y. Then Jacobian equals to ab. And the range r dash equals to capital X square plus y square equals to 1. Then we get double integration r dash 1 minus capital X square minus capital Y square ab dx dy equals to ab double integration r dash 1 minus x square minus y square dx dy. Then putting x equals to r cos theta and y is equal to r sin theta. Then the Jacobian equals to r. Then the region b r tends to 0 to 1 and theta is to 0 to pi by 2. Putting we get ab double integration r double dash 1 minus r square r dr d theta equals to ab integration 0 to pi by 2 d theta integration 0 to 1 r minus r cube dr equals to ab into pi by 2 into r square by 2 minus r to the power 4 by 4 in the limit 0 to 1. ab into pi by 2 into 1 by 2 minus 1 by 4 equals to ab into pi by 2 into 1 by 4, that is 1 by 8 pi ab. This is our answer. If you find my video is helpful for you, please like and share and also subscribe. Next, the next example. Prove that double integration y e to the power xy dx dy where r equals to 0 less than equals to x less than equals to a and 0 less than equals to y less than equals to b exists and is equal to 1 by a e to the power ab minus 1. Now start the solve. Double integration r y e to the power xy dx dy equals to integration 0 to b y dy integration 0 to a e to the power xy dx equals to integration 0 to b y into e to the power xy by y in the limit 0 to a dy. Then solving we get our required answer 1 by a into e to the power ab minus 1. Now start triple integral. Triple integration capital R f x y z dx dy dz. Number 1, f x y z be continuous in R. R the region bounded by the straight lines a less than equals to x less than equals to b, c less than equals to y less than equals to d. This is d. And e less than equals to z less than equals to f equals to integration e to f dz integration c to d dy integration a to b f x y z dx. Now our first example. So that triple integration dx dy dz by 1 plus x plus z whole to the power cube equals to 1 by 16 log 256 by e to the power 5 taken throughout the tetrahedron bounded by the planes x equals to 0, y equals to 0, z equals to 0 and x plus y plus z equals to 1. Let x, y x plus y plus z equals to u. X plus y equals to uv and x equals to uw. Then y equals to uv into 1 minus w and z equals to u into 1 minus v. Then find the Jacobian. We get Jacobian equals to u square v. Now the limits are changed to this. We get u v w equals to 0, u v equals to 0, w equals to 1, u equals to 0, v equals to 1 and u equals to 1. Then the Ardous region is u v w tends to 0 to 1. Triple integration r triple r dash u square v du dv dw by 1 plus u whole to the power cube equals to integration 0 to 1 dw integration 0 to 1 v dv integration 0 to 1 u square du by 1 plus u to the power cube. Then putting 1 by u equals to m. Then we get 1 into half into integration 1 to 2 m minus 1 whole to the power square dm by m cube by m cube equals to half integration 1 to 2 m square minus twice m plus 1. Applying the formula a minus b whole square, then by m cube dm we get half integration 1 to 2 1 by m minus 2 by m square plus 1 by m cube into dm. Then solving we get 1 by 16 log 256 by e to the power 5 proved. Now spherical coordinate system. What is spherical coordinate system? The equation of a sphere is x square plus y square plus z square equals to a square, and for hemisphere theta tends to 0 to pi by 2, phi tends to 0 to 2 pi. What is theta and phi? This angles is phi and this is theta. For sphere theta tends to 0 to pi and phi tends to 0 to 2 pi, and x equals to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta, and Jacobian equals to r square sin theta. Here I make a table for better understanding. See, for hemisphere r square equals to a square, r tends to 0 to a, theta tends to 0 to pi by 2 and phi tends to 0 to 2 pi. For sphere r tends to 0 to a, theta tends to 0 to pi, phi tends to 0 to 2 pi. A positive quadrant r tends to 0 to a, theta tends to 0 to pi by 2 and phi tends to 0 to pi by 2. Now start the example. So that if r be the ellipsoid, x square by a square plus y square by b square plus z square by c square equals to 1, triple integration r root over of a square b square c square minus b square c square x square minus a square c square y square minus a square b square z square dx dy dz equals to 1 by 4 pi square a square b square c square. Now start. Triple integration r root over of x square b square c square minus b square c square x square minus c square a square y square minus a square b square z square dx dy dz, where r the region is x square by a square plus y square by b square plus z square by c square equals to 1. Then putting x by a equals to capital X, y by b equals to capital Y, z by c equals to capital Z, and the Jacobian is ABC. Then solving we get triple integration r dash a square b square c square root over of 1 minus x square minus capital Y square minus capital Z square dx dy dz, where I dash equals to x square plus y square plus z square equals to 1. Then also putting capital X equals to r sin theta cos phi, y equals to r sin theta sin phi, z equals to r cos phi. Then the Jacobian is r square sin theta, and the region be r 0 to 1, theta 0 to pi, and phi is 0 to 2 pi. Then putting these limits, then let r square equals to z dash, and then solving, applying the beta gamma function, we get the answer 1 by 4 pi square a square b square c square. This is our answer. So my today's topic is end. If you find this video is helpful for you, please like and share and subscribe our channel for more videos. Thank you.